Have you ever looked up at the night sky and just wondered what's out there, past everything we can see? It turns out, we're surrounded by a cosmic curtain, a boundary in time and space that we literally can't look past. But what if we could take a peek behind it? Today, we're going to explore what top scientists think is hiding just beyond the edge of our reality, from an endless sea of galaxies just like ours, to clues about the very beginning of time itself. To figure out what lies beyond, we first have to understand the boundary itself. And no, it's not a physical wall or some kind of literal edge. The best way to think about it is like being on a ship in the middle of a vast ocean. You can only see as far as the horizon. That horizon isn't the end of the world, of course. It's just the limit of your vision. Our universe has a horizon just like that. And the reason for it is actually pretty simple. The universe isn't infinitely old, and light doesn't travel infinitely fast. The Big Bang, the event that kick-started everything, happened about 13.8 billion years ago. That means that light from the most distant things we can possibly see has been traveling for 13.8 billion years to reach our eyes. Any light from anything farther away than that simply hasn't had enough time to get here. It's a perfect, impenetrable veil, drawn by the laws of physics. Now, this is where it gets really weird. You might think this makes our universe a sphere that's 13.8 billion light-years in any direction. But it's much, much bigger. The actual diameter of the observable universe is a mind-shattering 93 billion light-years. How is that even possible? Because while that ancient light was racing towards us, space itself was expanding. The very fabric of the cosmos has been stretching the whole time. So that little patch of space that sent its light our way, 13.8 billion years ago, has been carried much, much farther away from us. Imagine two people walking away from each other on a giant, expanding rubber sheet. After an hour, the distance between them is way more than just their combined walking distance, because the sheet under their feet stretched. So, this sphere, 93 billion light-years across with us right in the middle, is our personal bubble of reality. It's got every star and galaxy we could ever hope to see. But it begs the biggest question in all of cosmology. What's on the other side of that cosmic curtain? So, what do scientists believe is hiding just beyond that veil? We can't see it, but we can use the laws of physics and what we see in our own cosmic neighborhood to make some pretty solid guesses. And the theories range from the beautifully simple to the downright bizarre. Okay, the simplest and maybe most likely answer is that beyond the edge of our observable universe is, well, more universe. More galaxies, more clusters, more superclusters, and more huge, empty voids stretching on and on, maybe forever. This idea comes from something called the cosmological principle. It's a fancy term for a simple idea. On the grandest scale, the universe is pretty much the same everywhere and looks the same in all directions. There are no special spots, and there's no real center. So far, everything we see supports this. The way galaxies are spread out, the even glow of the Big Bang's afterglow, it all suggests we're not special. If that's true, then our 93 billion light-year bubble is just one tiny, insignificant patch in a much larger, maybe infinite, cosmic quilt. Somewhere out there, an observer in a distant galaxy has their own bubble, seeing parts of the universe we can't, while some of what we see is beyond their horizon. In this view, the universe just keeps going. But what if the universe isn't infinite? This leads to our next mind-bending idea. The universe could be finite, but have no edge. It sounds like a paradox, but you experience a 2D version of this every day. The surface of the Earth is finite, but there's no edge to fall off. You can go in one direction forever, and you'll just end up right back where you started. The universe could be the 3D version of that. While our best measurements suggest the universe is geometrically flat, it might have a very slight, large-scale curve. If it curved in on itself, you could fly in a straight line for an unimaginable amount of time and eventually end up right back where you started. One of the wildest models for a finite universe is a 3D donut shape called a torus. In a universe like this, if you flew out the top, you'd instantly pop back in from the bottom. Exit stage right, and you reappear stage left. It's a perfectly self-contained cosmos. This opens up an incredible possibility. Some of the distant galaxies we see might just be ghost images of our own Milky Way, from light that is wrapped all the way around the universe. We haven't found any proof of this, but it's a wild, mathematically sound possibility. All right, let's get weird. Our final theory is the big one, the multiverse. This isn't just one idea, but a whole family of them, all suggesting our universe isn't the only game in town. One of the leading multiverse theories comes from an idea called cosmic inflation. Inflation says that in the first tiny fraction of a second after the Big Bang, the universe exploded in size, growing from smaller than an atom to absolutely colossal in an instant. The theory of eternal inflation suggests that this process, once it starts, might never fully stop. It's like a cosmic chain reaction. While inflation stopped for our patch of space, allowing our universe to cool down and form, it could still be happening elsewhere, constantly blowing up new bubble universes. Each of these bubbles would be its own universe, totally cut off from ours. And what's more, the laws of physics inside them could be completely different. They might have stronger gravity, weird particles we've never dreamed of, or even a different number of dimensions. Our universe, with its laws perfectly tuned for life, might just be one lucky bubble in an infinite cosmic foam. Proving this is insanely hard, but some scientists are looking for faint clues, like strange bruises in the afterglow of the Big Bang, the potential mark of a collision between our universe and another long, long ago. Now, these ideas aren't just pulled out of thin air. They're based on real clues the universe gives us. The most important clue we have is the cosmic microwave background, or CMB. Think of it as the universe's baby picture. This faint glow of radiation is the oldest light we can see, a snapshot from when the cosmos was just 380,000 years old. It's the glowing wall of our observable bubble. Scientists scan the CMB in incredible detail, mapping its tiny temperature differences. These patterns tell us about the universe's infancy and mostly confirm our standard model of a hot, dense beginning, followed by expansion and cooling. They strongly point to the universe having a flat geometry. However, there are some strange puzzles left. Some controversial studies have pointed to a phenomenon called dark flow, where huge galaxy clusters seem to be streaming in the same direction, pulled by something enormous lurking just over our cosmic horizon. Other oddities in the CMB, like a massive and unexplained cold spot, or a weird alignment of patterns some call the axis of evil, don't have an easy explanation. They leave the door open for more exotic physics, maybe even hints of a looping universe or the multiverse. Meanwhile, new data from instruments like the Dark Energy Spectroscopic Instrument, DESI, is adding new twists to our understanding of dark energy, making us question whether it has truly been constant throughout all of cosmic history. So what's really out there? An infinite ocean of galaxies? A cosmic hall of mirrors? Or an endless foam of bubble universes with alien physics? The honest answer is, we don't know. And we might never know for sure. That cosmic horizon is a fundamental limit. But the fact that we don't have an answer is what makes this question so powerful. It pushes science and our imaginations to the absolute limit. The clues we piece together from ancient light and the dance of distant galaxies are part of a puzzle that's billions of years old. Humanity has always been driven to look beyond the horizon and wonder what's next. That horizon has expanded from the next valley to the other side of the ocean, to the planets, and now to the very edge of light and time itself. Trying to figure out what's beyond our cosmic bubble is just the next step in that journey. It's a reminder that we live in a universe of profound mystery and endless possibility, and that the greatest journey is the one that expands our understanding of our place in it all. We're always exploring the biggest questions out there, so if you're as fascinated by this stuff as we are, make sure to subscribe and hit that notification bell. So, which theory gets your vote? An infinite expanse, a donut-shaped cosmos, or the multiverse? Let us know your favorite theory down in the comments. Thanks for watching.